Great. Thank you, Dustin. You saved all of the bacons. Yeah, I think we're about ready. I'm just posting the link to the live feed right now. Okay, what? I logged in with the wrong OAuth token. Gosh. Okay, this is.
Get you another little big one.
Yeah. Okay. Okay. I think we're live. There might be some people joining over the thing here, but should we wait for this group to come in? Yeah. Sorry, we took it. Yeah. The screen's super. And it's the I mean, not as thin as Hey, you look so familiar. John called me. Yes. Yes. We have touched base like once a year. Yeah, right. That's been a lot. How are things? Good, man. Really? Oh, cool. All right, well, welcome. So, like that is actual space. No, I'm still staying. Vivid owns space. Okay. Yeah. I feel like you were constructed between nosing and space. Okay. Yeah. Yeah. Yeah, good to see you. Oh, that's a great question. Jeff, how long have we had Cassandra in production for? Yeah, I know we did. Oh, well, it was the beginning of this year, but yeah, we've had it in production for almost a year now. Well, it might have been in production for also. That's true. Probably not exactly a year. Yeah. That's the way it is. Yeah. I don't even know the answers. Here's what I know. I know that we're using the Partition. And if you load our op center, yeah, so I've got a little yeah, like we know enough to support a very big query. We have to support a very big query. Yeah, I just need right now our native model. Wires that we very stuff in order. That's the only problem. You said it's a point provider, primarily for business users. Like all the docs say don't use the take that. I think so. So let's just quickly get started on introductions. That way we can share cell. Oh, it's all you guys ready to get this going? So let's go around and do introductions real quick. Just briefly, your name, where you're from, why you're interested in Cassandra, and then we can start. So I'm JT. I work at Space Monkey. I guess I host this meetup. I'm interested in Cassandra because we've had Cassandra in production for about a year, and I'm really convinced we're doing it wrong. So
now the year's about the right market to actually figure out how to do it.
Yeah. It's been that long. We don't know. Yeah, let's just go around.
I'm Stuart Jansen. I'm from planet Earth, and I like to play with computers. I'm Levi Person. I work at Harvard International doing networking. And not so much interested in
And specifically, different topics.
And pretty cool.
My name is Cody. I work across the street over at Newbie. I'm interested in Cassandra because it's built on top of Amazon's Dynamo model. It's a really interesting model. Want to hear more? Okay.
I'm Elliot Setzer. I'm unemployed, hopefully temporarily, but it's a little unclear. And I've heard about Cassandra.
You want to go, Jeff?
Sure, I'm Jeff. I also work in space when we had Cassandra in production and been called to the design president sometimes. So, but they're kind of not have that happen. Yeah, she's got these on. Yeah, she is. Okay.
I'm Jordan. I just learning how to program, so just learned SQL. So this is the next step.
Welcome.
So having learned this, you now going to unlearn.
So I work at Little Side across the street. We've had Cassandra in production for a while now. I've only been there for a few months, but I'm just trying to wrap my head around it. Sweet.
I'm Dustin, I work in space working every developer. I'm Jeff Owens, I work at Alger and at Cassandra.
Great. You told me I work in Alger as well. And started at okay.
Dave Stevenson, work for Simple Nexus. If you want to vote on the Utah Valley, Hot 100, vote for Simple Nexus.
Or Nexus.
No. And I came here to Jared and speak because we used to work together.
Chad here can work at Far Better, which is just on the other side of the street over here. And we actually use DynamoDB, which is kind of the managed version of Cassandra for those of us that are lazy. So interested in learning about the
Okay. Ready to make ice cream? I kind of. Actually, I worked with same place today, a guy named Mark Barr, who's really Far Better ice cream. So we always love the name right there. Far Better something. Okay, so yeah, we're going to turn the time over to Jared. Thanks everybody for coming, and then I'll talk a little bit at the end about this meetup and what's coming up next. So, great, Jared, thanks.
Okay. So, thanks again. I'm Jared Alger. I work for Ancestry DNA. I manage one of the backend services team that processes our DNA matches. And I'll get into the topic of what we do and back on that a little bit later. My production system, Cassandra, has been in place for 2 months, so you guys have been in production or actually ahead of me. We had a prototype, and it took us a while to get it actually in production because we had to make our database, which is a rather large SQL Server database, identical in Cassandra, which turned out to be actually the hardest part of making those two state systems in sync during that 1-day migration period, and figuring out all the issues that we had there, which gave me a lot of really cool, interesting insight into how Cassandra does its distributed pieces. It does have fixes for it, so it's great, but it makes sense once you understand how to use it. So I'm going to be kind of basic, at least on Cassandra, as far as the distribution nature of it. We'll get into some specific topics and I'll go over that. But as far as a little introduction here, some of you guys are all working on embedded systems, some of you are working on systems at a higher level. Obviously, a few of you are at least experiencing the desire to deal with the data, sharing using Cassandra, and that's kind of becoming the norm in our industry. It used to be, we'd hear people say, oh, when you get to that kind of scale, or they have that data record kind of database, we'll deal with that bit, right? Well, most people are getting there a lot faster than they used to. And us at Ancestry are no exception. But at the same point in time, our customers want fast response times. They also want 100% of the time, right? Compare it out, I want 6 nines or 10 nines after 9. That's my points, right? And at the same time, business also are wanting these active data center systems where you have an active data center, another active data center in Europe, so that those can have fast response time, no latency, redundancy, if one goes down, it immediately tells them. Another one, automatically clear out everything, 100% active, no downtime, 0 issues. And that's one of the reasons why Cassandra can excel with that. It's got all that built in. The other thing, the reason why I think this is rather interesting to cover is relational databases are great. They've been around for 40 plus years. They have their issues, but they work. For the most part, we all understand once we've learned SQL roughly what to do. There's nuances between each one, but they work. However, they're not always great. Try doing abstraction with Oracle or MySQL, Postgres. It's a little bit more difficult, right? So the other thing I want to set up front right now, ask questions. I have a tendency to start talking about stuff that I have not covered or explained, such as active when I'm practicing this. You guys have paper next time. I'll explain it to you. Just tell me, hey, type up, don't hesitate to interrupt. I got slides, tell them to catch it up. So all good. For our agenda, which I should have sent out earlier, sorry about that. We're going to go over our ancestry.com use case within DNA, this Cassandra, why we went and used Cassandra in our group.
Am I too close
I
to the
can
microphone?
briefly touch on some of the other groups that we are in Cassandra and DNA in ancestry. Then I'll talk about what is Cassandra. I'm going to cover in that area the distributed nature. Okay. Hopefully, that's where you have a lot of questions that we can cover how it works, why it works the way it is, how it's distributed, and things like that. And then we'll go through a live demo. It's very basic. You learn how to insert, update, delete, why things work, what they do, explain a few things. I also plan to cover some issues that we ran into during our migration, which is why it took us like a month to actually say we're done and I'll migrate the data and oh, it messed up. We're going to why that kept running and surprises for us. Okay. Any questions so far? All right. So at Ancestry, these are just a few of the different products that we have that use Cassandra. DNA is one I'm working on. There's another DNA group that's doing a Cassandra piece for our part of our third-party partners who are working with us. There's Kinship, Tree Cache, Big Tree, Notables, Discovery, Tree Services. We have a key document store that everybody can use. We have our search services in our e-commerce piece. All of these different systems all use Cassandra. One of the tree ones is a 50 or 60 million cluster. But I do records in that system. I believe it's somewhere in the order of not quite 100 million, but close to that, in a million trees. Like 60 or 70 million trees that they have. Some of those have 5 nodes in them, some of them have 5,000. Right? So they've got a lot of data in their system. So DNA matches. We have a reason, very clear cut reason to use it, and that's exponential growth. So when we have 200,000 tests, DNA kits that people take, we'll spin in a tube, right? And if you spin in that tube, we send it off, and they can extract the data out of that and see who you're related to. We have one DNA test for our database, right? You have 0 matches. When I get 100,000, you've got, say, 1,000 matches, right? And if you're from India and this is in the US, you have 0, right? But so it's different for different people based on who's using the system, right? My manager's from India, and we have 1.3 million tests now. She has 7 matches. I have something like 12,000. So it's going to differ for everybody, but as a rule, the more records we get, the more people we have matches with, and it just grows massively exponentially. Just since June, I think it was 1.3 billion records I've added to my database. We're over 6 billion records. That technically that's over 3 billion matches, but we have A, B, and B, A because we want to make it fast for searching, and so we deal with that. So but then also the users can set their own values. You can mark them as a favorite, you can mark them as red or unread, and add notes. That way, I have notes on you, that you don't have any notes on me. And for us, our growth trend is just worse. So here's where we were in 2014. Here's where we are in 2015. This is actually a low estimate based on our product estimates. 2016 is like a 4x. 2017 is really bad. 2020, I'm over 2 trillion records. And that's if the product is right on their estimates, which so far they've been underestimating themselves. They've been exceeding themselves, which makes us even scarier, right? Which is why we said, okay, we're done with SQL Server. Whereas the company is done with Microsoft in general. So we're switching away from Microsoft entirely, which is just another reason to do it. And so that's kind of a really compelling use case for us for using Cassandra. We need to have a ton of data, right? We also need to be able to scale. Ancestry wants active everywhere. At a minimum, I would say it's one of those things they want to check the box in case they can go public again or whatever they want to do there.
What is active?
Active is when you have like a West Coast, East Coast
Oh, okay.
data center, those multiple data centers, all active, 100% working in isolation, but also shared, replicated, right? Okay. And Cassandra is one of those things that gives you that. It's built in. We'll get into that a little bit later. So, background of Cassandra. It was developed at Facebook for index searching. Not too long afterward, they realized that there's this eventual consistency that they don't like. They dropped it. Then Facebook bought Instagram at some point in time. So now Facebook actually has Cassandra there. There's a bunch of other companies that are using it. It's open source in 2008, Apache 2010, which means it's been Apache for 5 years. Seems like it's a long time in the software world. Put that into perspective. Databases, it's a new one, right? Oracle's been around for, let's see, 40, 52, same thing. Right? They've got their issues, they've got their pros and cons. They're relatively people know what they are. Cassandra isn't so much there, it's constantly changing. It's a much faster scale at which it's changing. I think Cassandra 3.0 is just about out. It's released, but not in the stable release. So, and that's what we'll go over today a little bit too.
Can't get a Java driver for it.
What's that?
Said Java driver stable.
Yeah, we're using a Java driver. So we're handling on a daily basis. We're adding 30 million records to our database.
So
Yeah, it's working very good. The .NET driver had some issues, but it works too. They're using that because we border our shots. We're switching to it's working quite well too.
switching to
I believe that tree one, our tree database, that one was like 50, 60 nodes. That was solved on it. As far as I know, I could be wrong, but I think it is. So, now, Cassandra it's a peer-to-peer server. They have no master server. They have this concept of seed nodes, which is the nodes that are like your core nodes that you start up your cluster with. They're there for one reason only. To start your cluster, and I guess to start your connection to the cluster. Technically, any node could be a seed. If I had a node that's dead, I don't want to pull it out of my thing and it was a seed node, I just decide that another node is a seed node. And it's in the configuration when I bring up a new node. So I have one node that was added to our cluster 6 months ago. It thinks that servers 1, 2, and 3 that are seeds. My new ones, I'm getting ready to bring out new ones. I'm ready to retire 1, 2, and 3 because so I add 8, 9, and 10 as my new seed nodes for all my new servers. And then I pull out 1, 2, and 3. Eventually, then I'll consider the seed node. And again, the seed node is just how do I find out what all the servers are so I can go ahead and start adding myself and getting data and start to become part of the cluster. Same thing on the connection. You just tell it, I want to talk to 5, 6, and 8 as my seed nodes. It talks to one of those in order. They're basically failovers for your clients to talk to. And then once they talk to one of them, that one tells them about the whole network. And at that point in time, the driver just talks to whichever one wants to do that. So it's truly a masterless system. New nodes are added very easily. You tell the node what the seed server is, configure it. And configuring it is a little bit complicated, but usually you get that figured out at the beginning, and you just maintain that same configuration going forward. You add it will draw off data from all the other servers and add it. It just automatically happens for you. And then as soon as it's live, it starts responding to traffic. Pretty simple. It's automatic. You just add it. There's work involved. You can automate that work. So record replication and multi-data center replication, all of that is built in.
Quick question. Obviously, you're growing really fast. You're adding new nodes all the time. Have you ever had to remove nodes, and is that easy to do? Or
Yeah, it's just built in. You tell it to decommission a node to pull it out. There's actually some rules in there. So let's pilot this real quick. Let's say I have a 12-node cluster, and one of my nodes goes down, and it's a physical hardware failure, and I don't want to rebuild it. It's tough. So I tell my cluster, remove this node. It's now an 11-node cluster. I bring up my new server, let's say I replace the hard drives, start out from scratch, and I add it. And it just adds back. That's it. So I gotta.
What if you didn't want to add a new, what if you just have less data all of a sudden? How long does it take to reshard the?
All depends on how much data you have, how fast your drives are, how big your network, fast your network is. Purely dependent on the amount of data. So there's actually kind of a rule on that in terms of when I went to the conference, I asked a lot of people how big the node should be. Data stacks, enterprise stacks, those guys, 500 gig, because they charge per node, right? So they're going to be really low on that end. They might lowball it, right? Some of the guys are saying 2, maybe 3 terabytes is the biggest thing.
How big are your nodes?
I believe, let's see. So it's 40 gigs and I have 12 clusters, 12 nodes. So a little bit over 3 terabytes each. 40 terabytes, not 20, 40 terabytes. I haven't adjusted. Okay. But yeah, so the other thing I was going to say, I'm like, if a node goes down for more than 6 hours, and this is configured over time, I think the default is 6 hours is your handoff time. It's also your time where they have a concept of when you delete a record, it's called
Tombstone.
the delete a record. Yeah, tombstone. It creates a tombstone to say that this record's gone. And if a node goes down and it is gone down longer than the lifetime of that tombstone, or the lifetime of the 6-hour thing. There's a 6-hour thing and then there's the tombstone lifespan. But if you exceed that time frame, you don't want to re-add that, restart that node. You want to decommission the node and restart it. There's some time frames and some things you want to keep in mind on that. Because what can happen is if you, let's say I exceed the time frame of the tombstone, and we'll get into this, but you delete a record, you create that tombstone, this node goes down and never finds out about that delete. And you bring it back up, it knows about that record, and that tombstone is gone. It's now going to replicate that fact that record still exists back in the system. You can make data come back. And I'll explain that a little bit more how that happens when we kind of get into how the data is stored in the database and what happens. Okay. Anything else on that? Okay. They also have the concept of snitches. And snitches is a really interesting thing. What a snitch is used for is to decide where and which nodes a particular data item should be replicated to. So imagine if I have a 12-node cluster and I have a rack in my data center. I have 4 racks. Each rack contains 3 of my servers, okay? And I have a replication factor of 3, which means each record is stored on 3 of the servers, okay? If I pull the plug, because I'm a goofy network guy, I was walking by and tripped over the power cord, I tripped over the network cord, this whole rack's toast, right? There's 3 servers in there. If my record is on those 3 servers, and it could be anywhere, right? Any one of them is just distributed. If it's on all 3 of those, that record is no longer accessible. You cannot query it, despite the fact that it's right. Snitches are used, and there's a bunch of them, different ways, different strategies. They're basically just a strategy for storing data. It can make it to that my record is in rack 1, my second copy is in rack 2, my third copy is in rack 3. It can make sure that you configure that and take care of that system. So you have even more redundancy and safety in that regard. So with that, I'm going to go into how this works. So I was hoping this would be lower, so it'll be trying to use the mouse to point. So if I have my application, I'm going to make a write or a read to this cluster. Again, remember this, totally masterless. My client may or may not know, I think one of the clients actually has, if you use it a certain way, you can actually have it know which nodes your record is. So if I have a record, I'm going to go read it, just talk to node 1. Node 1 looks at my record that I'm trying to read or write, figures out that, hey, this record is stored on node 2, node 3, and node 5. So it's going to issue a request to those guys to either do the write or the query. And then they'll return back. And you have a thing called tunable consistency. So I can tell when I create that query, I can tell it, I want you to read from 1 node. And by the way, this is a ring with a replication factor of 3. You can choose a replication factor. It could be 1, it could be 5, technically it could be 2, but then how do you handle discrepancy between 2, right? You want to have an odd number so you can read the concept, I'll get to next. So let's say I want it to read 1. If I say read 1, this still responds back in 5 microseconds. I get my response in 5 microseconds. If I use what's called quorum, okay, quorum is a read or write consistency that says I want 2 out of my 3 or 3 out of my 5, depending on my replication factor, responses back. And once those come back and they all agree, I can respond back. Okay. If I do a 2, it's going to send it to 2, send it to 5. It responds back after 8 microseconds, and now my coordinator node can respond back to my application. I get an 8 microsecond response time. I can do all. If I said all, then all 3 of them have to respond, and I get a 20 microsecond response time. Does that make sense? Same thing on the right. And this is kind of how it defines you can control that from your application on a query by query basis. What you want to do on your consistency. Now, if we go to a distributed data center, this is my West Coast data center. This is my East Coast data center, right? I am out in California, so I report to Utah or whatever. I write to this data center. I talk to this one. It goes to the coordinator and tells these 3 guys to write, and I do quorum, so 2 will respond back. And if I did local quorum, so there's local quorum and quorum. Local quorum, as soon as I get 2 responses back from here, let's say it's the 5 and 8 microseconds, I get a response time of 8 microseconds. Now, this WAN connection gets kicked off. Let's say that's a 3 second, because I get a really crappy WAN connection. And it comes over here, talks to the one node, and then talks to the other 2, because it's going to be smart. It's going to know which one to talk to, so it'll at least talk to one of the 3 that's in the partition key. And I'll talk to those 2, and it'll take care of the writing. And that is what's called the eventual consistency. Okay? So eventually, my East Coast data center will be consistent with my West Coast data center. And same reverse, if a guy talks to the East Coast guy, and he writes it to 3, and then it sends it over to the West Coast. That kind of makes sense? It's very distributed. I don't have to configure or know about any of that. I just say, write this record. And I decide what consistency level I want it to be at.
Are you a multi-data center or a single data center?
Right now, we're single, and we plan to be multi. They're trying to figure it out. So, and the reason why I mentioned snitches, when the guy set it up, I didn't double check our snitch policy. They're using a simple snitch, which does not support multiple data centers, which means I've got to completely rebuild my cluster or change my snitch policy, which means all my data is going to get rebalanced, which is scary. I don't want to do that in prod and try to replicate that in a stage environment. I've got 6 billion records, 15 terabytes of data. I don't want to try to do that stage. At this point, since I have dual write, I might just burn down all the cluster and start. But since I have dual write still going on, I have that freedom. I also have some new things coming up that may make it where I don't even need to do that. Take some data. I don't care. Very nice data on the data center. My new data will be in the new system. We're constantly refiguring all our algorithms and changing chips and things to try to improve our customer things. So we might not even have to worry about that. But you might not have that luxury, especially if you start from scratch. My next one, I guarantee I won't have that luxury. I won't even have secret server. But because we started with secret server migrated, I can do that. But that's something you want to make sure you check on and don't make the same mistake. The other groups in Ancestry knew a little bit more, and they didn't do that. We thought that they'd take care of that, but we didn't. The guys didn't. So tunable consistency, that's what I was talking about, where you can choose write 1, write quorum, write local quorum, or write all. Make sense there? The reason that's actually really important is that whole eventual consistency thing. Let's say I have 1 data set. If I write quorum and I read quorum, that guarantees that I'm reading from 2 and I'm writing from 2, which means my consistency level is 3, and I'm talking to 4 nodes between those 2 things, right? Yeah, there's 2 and then the same 2 for the other one. As long as your total on your read and writes is more than your application, you're guaranteed, not eventual, guaranteed. That makes sense? So same thing happens if I write all, so I write the 3 nodes, and I read 1, I'll get my fastest one back. I can make my writes deal with the pain of the slowest machine, and let my reads be really fast. However, if you do that and 1 node goes down, you can't run it. So that's why most people tend to do local quorum and local quorum. And then if they're on, and then you do West Coast, East Coast, they move into core and core, deal with local core information. Makes sense a little bit? Okay. It's a distributed storage system service, I kind of explained. It quickly handles large amounts of data. Our 12 node cluster has, each one has a SSDs in it, 40 terabytes of data. I had 12 servers reading from SQL Server trying to, I think I actually had 20 servers reading from SQL Server trying to massage the data and put it in a standard format. I could not make it break this way. It's got, it's green, yellow, and red on the option of tool showing you the status of the load on the servers. I got one server that got a medium when I had 6. When I had 12, I couldn't get it in. And so 20 servers could feed 12 We're about at 300,000 ranks per second. Converting my 5 billion records, or 6 billion at the time when I did it, took less than 24 hours. It would have been even faster if I'd gotten more servers in the client. It's a one-time thing that I did like 10 times to figure it out, and should have been a one-time thing. But we had to but it can handle tons of things. It can handle really fast too.
How big are your records?
So that's rather interesting because we'll kind of explain that. Cassandra is a wide-open database, so it varies in terms of Cassandra. But our logical records, these things are in a SQL Server or RDBMS side, they're actually pretty small. We have 2 test goods, a couple of flags, and a user can have for text notes. Not very many do, so they're actually pretty small. But I'll talk about why that's an interesting question a little bit later. The other thing, this is the snitch thing again. Those are the different types of snitches. They have some for Amazon, Google Cloud, Cloud Stack. This simple snitch is the one we got stuck with. The gossiping property file one and the rack and query one are rather interesting. So let's say that I have my 4 racks again in consumer use, right? If I have a network IP status, internal network IP that says that the 3rd octet is the rack and the 4th octet is the server in that rack, right? So in my network IP, right? If I have something like that, I can use a rack inferring thing, and you can also do a custom. But I can have a rack inferring topology on our snitch that says automatically, just based on the IP address, knows that these guys are in rack 1, these guys are rack 2, these guys are rack 3. Pretty cool. Or I can go to a property file because my IT guys can't figure out how to do that, and they just stick randomly, I assign IPs. You go to a gossiping property file, and all you've got to do is say, this is rack 1 and node 1 in there. Or it is take care of like that.
Can you chain snitches together or give multiple snitches different priorities based on the characteristics of the data?
So you have one snitch policy, and what the snitch is doing is taking we'll get into it a little bit later, but a thing called a partition. And a partition key is what's used to decide it's basically hashed and says, this record is going to go on 1, 2, and 3. This other record is going to go on 4, 5, and 6. And the snitch is just involved in updating that strategy to decide where they go. So if you have different snitches, different topologies, you're going to have all. How would it do that, right?
So you just change your routing key instead of.
Well, yeah, but the routing keys are consistent for the entire system. So if you have one doing it one way and another one doing it another way, I don't think it would do that. It might, but that would seem really, really, really hard for Cassandra to figure out. Maybe it can, but I don't believe it can. I personally would definitely test that before I try it.
My thought was if you had a general data cluster and wanted to spin up specific client clusters that were completely external from the general data, you could still filter it through your system, but it would route all their records to
So if you're talking about data centers, yeah, if you're separate data centers.
data cluster, a bunch of servers or something.
Yeah, so you could take in one data center and say, these 6 nodes are data center 1, these 6 nodes are data center 2, have totally different strategies for each of them because they're in a different data center. Because your data is duplicated in each data center. But again, so what they do, I'll go into that real quick. If I have a record and I have 256 partitions for my cluster, that's going to take my total set of possible records, and it's going to distribute and these little micro segments, all the data, this server, so it's 6 server ring that you can work. And I have 256 items in my partition key system. This guy's going to get 1/6 of those 256. This guy's going to get another 1/6, and another 1/6, and then they'll have a second 1/6 because we got to do replication of 3. He'll have a second 1/6, and he'll have a third 1/6. That makes sense. So having different snitches, where this guy's using this other policy and this one's a different policy, I don't even think I'd want to write that. It'd be really, really weird and hard to do. They might do it. They got smart guys. Okay. Any other questions on that? Okay, so again, as far as database is concerned, it's fairly new, but it's improving fast. Got a lot of nice things. DataStax Enterprise, their DataStax themselves, at least when I put in the conference, they were claiming that they were going to drop support. So unless you have the DataStax Enterprise product from them, you have the open source guy, you have to get support from somebody else. You can't even teach them. They're not willing to take money from them because they want to sell their enterprise service. It's rather expensive as far as what I've heard from people that are part of the option. They were willing to pay for it. So, in fact, they were actually potentially considering writing their own backup and different things. There's also a lot of open source guys that do connectors to Spark and connectors to Solar that kind of do what they do. So they're trying to keep people buying their product and not just paying for support. Kind of the other thing is, there's no joins, although we'll get into how you possibly do that. Can I simulate that? There's limited filtering because it's looking at how it's structured and why that's the case. Sorting is the same way, and there's no transaction. You go start transaction, write to 20 records, commit it, go back. There is a batch, which we'll get into, which kind of gets something similar, but don't confuse it with a transaction. It's not a transaction. With their 3.0 product, they have a thing that I'll go over, it's called materialized views. Materialized views actually do have a transaction involved. You don't get anything to do with it, and all of the covers you have no access to. So there's also no offset. So trying to say, I'm going to get page 20, and I have a page size of 20, you can't do that unless you actually know your key that for the the last item on the 19th page. You could jump that way. But otherwise, you have to actually stream all the way to get page 20, you have to go through pages 1 through 19. That kind of makes sense. There's no offset. You already get it.
If you're using DSE, use this DSE Solar project.
Yeah. Yeah. We're stuck with open source, so they don't have that. Technically, we did actually implement one that we offered as an option to our clients. Our app client isn't using it, but other guys might. But if you know what the 19th item is, you can start page 20 with that key for the 19th item and go get the next one, right? So you can do that. I'm guessing that may be how they're doing it. I keep track of that. Or they just have additional indexes. There you go.
It's using just Solar indexes.
Yeah, you're lucky you get to use the enterprise. That's cool. Okay, so here's some questions. Some of you guys are saying, you were looking at getting it together. Here's a question I grabbed off the web, and I tend to agree with some sites that more than repetition. Do you have a large data set like we have? Do you have a really high response times you need for that data set? Do you have, if those are your characteristics, probably a good fit, or possibly a good fit. But if you have rich queries that are constantly changing, one of the places I worked at, we were tracking at Nextpage, we're tracking all the files on the computer file system. That was a large data set. This was not be good for that because we had customers that wanted to take care of the data. Every single different customer had one of the custom query to figure out how to do their thing. Some of those queries would run for a long time. Some were faster than others. Some were bigger than others. So, I'm talking like 40, 50 lines of SQL to figure out how to join all these tables to say, I want these records to go away, right? And so they clear out their data. If you have that kind of thing, you're not going to train. People are going to just not going to handle it. If you have application transparency, so you have 20 different applications that depend on the database, and they all operate differently. I don't care if you have a SOL model and you have one server that provides that for all 20 of those applications and all their unique query nodes. You're going to be building a ton of custom indexes to support your form, which effectively is kind of a replica of your data. That's a lot of data. You have 20 different copies on top of 3. So you have 20 times 3, you have 60 copies. That's a lot of data. Probably not a good idea. The other thing is, we actually have that key document stored. We have a system, it's just key or value per. There may be others that are better, but Cassandra can support that very easily. We actually wrote one in Mongo, and then they didn't, our lawyers and whatever didn't like Mongo's licensing. So they said, kill it, rewrite Cassandra. And then questions on what is Cassandra before I go down line two. Yeah.
Excuse me. I guess I just don't understand, like, what part of the stack, or like, let's say I have my database, my Redis or cache, and all that stuff. Where's Cassandra trying to shine?
The database.
So, like, placing MySQL, and,
Yeah, MySQL is a database, Cassandra database.
but you use it as a key value too.
You can put any, I can do key value in a MySQL database, right?
But what's its optimal? Because it's not relational. So is it
Writing,
columnar data?
how would you writing lots of data?
Yeah.
How would you
have
feel
a
about
basic-
sending 1 million records a minute to your MySQL database?
Probably not good.
Yeah.
Cassandra Works.
Try doing that to SQL Server without it escalating.
Cassandra can just absorb writes.
Yeah. Like I said, we were doing 300,000 writes per second. It didn't bring us far. And the nice thing is when we go from 6 nodes to 12 nodes, let's say 6 nodes, you can't quite handle the load, right? It's starting to fall over. It's not handling, you get medium load or high load all the time. Add 6 nodes. Let's say I was doing 100,000 on that 6, totally that I did 100,000, add 6 more, double it, I should be able to do 200. And then hit that same variable. Add 6 more, just constant. It's totally linear scale.
It's true that Cassandra has better write performance than read performance, right?
Yes.
Yeah, that's a little unusual. I think.
It has pretty good read performance.
No, of course, but like comparatively, most systems have much better read performance than write performance.
Yes. It's kind of a spin around, right? But part of that is how it writes. So I'll take that as a segue real quick to see how it writes. Cassandra tries to keep everything in memory. So the first,
Tries or does?
what's that?
Tries or does? I was under the impression that Cassandra was in memory. Is it persistent?
Is
Okay.
persistence. So
Okay.
first thing I'll cover,
It's on disk format.
first thing I'm gonna do is how do I create my. Okay. So bear with me, I'm gonna be switching back so I don't have to type on this. And I need to close this presentation. Now I can hopefully see my screen, but you guys can see. Okay, all right. So I just created a splice. First thing I do, I create a key space. Okay, I'm gonna create this key space called isdb. Think of it as create DB on MySQL, right? Say I want replication of class network topology. This network topology or simple are your choices. The simple means I'm gonna have a single data center. Network topology means I can have multiple data centers. Right here, I'm saying this node or this is data center 1, or there's a data center 1 and it's got a replication factor of 3. If I had a second data center, or of 1, if I had a second data center with a replication factor of 3, I could do that. It would just be data center 2, 3. Make sense? So then I describe this thing. When I do the describe, it adds this other value that I left off. The default is durable writes is true. Durable writes are false, it's an in-memory database. If there's no guarantee that you're writing to the database, to disk or anything like that. Durable writes true, guarantees that when it writes a record, it is written to a transaction log. So when I write that record, that write of 3 that I had earlier, right, on that diagram, I write that, it puts it in what's called a mem table. A mem table is just how Cassandra stores its data. There's also a concept of SS table. An SS table is the same thing on disk. And then there's the transaction log, and as soon as I write that record, it's in the mem table, and it's in the transaction. So it can think of it just like the SQL Server replay, and it just replays up when it starts up. Now you have everything back in memory when you reboot your server because it went down 20 minutes ago. And then there's another concept called hinted handoff. So if one of my nodes goes down 20 minutes because they decided to, swap out a hard drive or something, or change the memory, replace a bad memory stick, and shut it down, pull the stick out, the new one in. They don't have to do anything. No fixing anything. The other nodes will automatically see it pop back up, and they started tracking hinted handoffs because it stopped responding, and then it starts sending that data over, and it just streams all that data through, and now you're back to normal. Your server's back together. At the same time, if I did a read request at quorum, and I got a response from node 1 and node 5 that was down, come back up, it'll actually do a read repair because it'll see that node 1 has new data. As a read repair, I've got a quorum. I don't have to have another node respond. That node that was behind, hadn't caught up, automatically fixed itself and repaired on a read. And then it continues to stream whatever else is going on. All automated. That's one of the really nice distributed natures of Cassandra. That's why it's a perfect fit for this distributed system. So now I'm using the database, this key space. I have to create it. And let's create our first table. Okay. By the way, can you guys all read this good enough that I need to make it bigger? Good. All right. Okay. So let's create a table. Ignore the fact that it's plural. I know I'm supposed to in the database, but it's easy. You got a person and a match. So this table is going to be symbolic of what we might have in our database. Me and JT, we're cousins, let's say, so we're a match, right? And I put in there a constants. We also would have some other values that we have in our database, but you guys don't care about that, so I didn't do that. We're gonna have a flag for whether it's red or not, and a flag for whether I starred it or marked it or something to say, flag this guy, because I think he's got all this cool data I want to talk to him, right? Just a simple example. Then we have a primary key. Now the primary key is made up of two pieces. The first one is your partition key. That's the guy that decides what nodes this record is going on, okay? And then the second part is your clustering key. And I'm going to switch to another thing here to kind of explain what that is. Okay, so if you look at our database, right here I have a partition key. That defines my row, okay? My second one is a cluster key, or keys, I should say, and then name value. So with my table that I have a person, that's the person. This is the match. This is the second match. this is the third match. So when Dave asked me how wide are my rows, I said, well, somebody that has 7, their row is this guy plus any values in here. If they're not null, they're not represented at all. And then the second one and the third one. So the person that has 7 has a much smaller width row than my next person. So in SQL, you would actually think of that like I have a match and I have a row, range match, right? But because my partition key is my ID for my spit kit that I spit in, right? And this one is yours. It's one row for that whole record, effectively would be many, many, many records in an RDBMS. And that's why it's called a wide row database. So this is the first record, my test. This one is JT's. And these are all of the people that we are related to in this matches scenario. Make sense?
Okay, I think we're going to review everything.
Sounds good. Okay, so that's kind of how the data structure works. One thing I will get into on this, with this person, you can have what's called a composite partition key. You just add a parenthesis, let's say person and match with my composite partition key, and then I had a bunch of other fields that I wanted to sort by and were my clustering keys. I would just have parentheses around those two, indicating that they're the first item, and then the other guys are just columns away. That confuse you, or that makes sense? Okay, all right. So let's go at the next thing. So I'm going to real quickly, I'm going to add a few records and I'll select from them. I'm just going to do 5 real quick, and then I'll kind of go over what they are. Okay, so when I added this first record, I insert that record, and it goes in. This is by the way, this is the CQL shell that you get when you're on a node, just built in, kind of like the direct thing you can do on talking to your database on that machine. The first node, my partition key, is going to define which server it's on. And this is, by the way, just a single node. It's just running on one plate, so it's not no clustering or anything involved. And then here's my partitions. And then these are my values, my non-partition values, just the values of the record, right? In terms of how these are stored in the database, because these are all nulls, when you look at the structure in the database, this is called name value pairs, right? So because I have a value for confidence, there's a value in here called confidence, and it's got a value. That's it. You can put a list, you can put a set, you can put a map in there. So you can think of it kind of because now I have a map of some values, and then it's a list going down. Make sense? Okay. Kind of analogous effectively to have a comma delimited column in an RWMS, but it's supported in here. It's not the same thing. It's analogous, but it's much better because it actually works as a list. You can do all your list operations. You don't have to split it or do anything silly like that. Okay, so if I add my second record in here, it's ordered. Even though I added this 0001 first, then I added the 222, then I have this 100 or 10B, and you notice when I do my query in database order, they're sorted 00, 10, 22. Okay, that's the clustering key giving you that sorted. So even though Cassandra is spitting them out in records, again, those are rows, or columns in that big wide row database for this guy. Then I get to my fourth one where I've added a new partition and a value, okay? And notice how it's 9A and 10, it's in reverse. This is actually in order. Basically the hashed value of that partition is being sorted. So there's no guarantee on your sort there other than you get your sorting on your clustering keys. That's where your sorting comes in. Okay? So when I have my fifth record here, it's it's 6A, 6B, and 9A. They're ordered in that way. And I just use UUIDs, which it supports for every gate. Now I'm going to go through real quickly. I'm just going to mark a couple of records as true, mark a couple as red, and we end up with this simple set of data here. In this, so first of all, those other ones, those were just inserts. These are just updates. And sorry for you guys that have been using Cassandra. This part is kind of a demo for you guys. Sorry about that. But so now I've got all these values in here, and they're sorted based on the match. No sorting at all here, right? Those are just values in the database. So let's just imagine that my product guy says, hey, you've got this nice little database here. We've got a bunch of conferences marked as red. I want you to give me a query to give me all the records that are red. Okay. So I take and I naively go and write that query, and the first thing I get is an error. There's no supported secondary indexes for the non-primary key. I'm not even talking about secondary indexes right now because you don't want to.
Just don't use them ever.
Yeah, just you'll do what we'll go over later, which is create an index table. And there's two ways to do that. It's Cassandra 3.0 now. But you can't query that. I will show you the next thing you should never, ever do. You can add this nice little allow filtering flag at the end of your query. Okay, so now imagine my 12 node cluster with 6 billion records. I just said to this database, go query every single record in my entire database from every single server and give me back all the ones that are red. Imagine my read performance in that.
Oh, you are naughty.
I just killed the whole thing, right? Every single spindle, not spindle, SSD just went nuts. And I just killed the server. Nobody can get any data. I killed the transaction. Not a good idea, right? I showed it to you so you could kind of see. Now here's the cool thing. Cassandra 3.0 created a thing called materialized views. Now a materialized view is what we'll talk about later. Is there's a do-it-yourself index table where I have to put the data in an index and take care of it myself. Materialized views is a way of doing that all by myself. However, I'll explain the syntax. I do not like it. It's really, really dumb. Well, partly.
So, here's my thought on material is used, like, you can't change the cardinality of the rows. How is it better than a secondary index? Like, what problem does it solve?
I'll show
Not
you.
solved by us.
I think we can kind of explain that here in a second. What I don't like real quick is this where clause. It's really stupid. You'll see it here in a minute. But simple syntax, create a materialized view. I do my select, so I want the person, I want is red, and I want match and confidence, because we're going after that is red. That if someone else will fill that product owners. Show me the red records, right? And then I put this where. This where clause matches my primary key for my material. And in this case, I'm going to say it's the person, so me, then is red, and then match. Now, my product owner initially said, I want to say, give me all the, and this is fictional product, but he said, give me all the records that are red. What he really wanted was for my test, my DNA test, right? Give me all my records that are red. But he didn't know that, and I didn't explain it to him. And let's just say that he actually did want all of them. And let's say that I put is red here first, which means it's my partition key, a Boolean value. Now I'm going to have a 20 plus database. I have a Boolean value. It's either true or false. Can't be null. True or false. At 20 nodes, you've got a hash of 1, and it puts it on nodes 1, 2, and 3. You have a hash for 0, false, and it puts it on 5, 6, and 7. Guess what the other 14 nodes are doing? Nothing. You just totally imbalanced your cluster because you had a bad partition key, right? You don't use a low cardinality field for a partition key. Not a good idea. Does that make sense why that's the case? Okay.
Well,
All right.
the entire meeting more than.
Yeah. There you go. So instead, we're going to say, product owner, you're nuts. You don't care about all the red. You only care about the user that's looking at the site. They only care about their ones that are marked as red or marked as star, right? So we put that as here, and then the second column is red. Third column is match for sorting. Right? So now we go through, and let's just say we now can select for person 9A, give me all of his records from this new view. This is why I think this thing is dumb. I had to say where person is not null because it's in my primary key. Match is not null, and the owner actually does that. And is red is not null. Okay. Why do I have a null value in my index when it is not null? I don't get why they have that whole row, the where thing. It does nothing. You can't say where is red is true, so that this view is just my true records. No, it's all the records in a different view, different sorting order. That's all it is. And it doesn't even exclude them. It doesn't even respect what the
That's all it's doing is it reorders your data.
Exactly. It just basically copies it all, mirrors it, and it gives you that transaction that's controlled by Cassandra instead of you. So, and they actually talked about this when they did that presentation of the Cassandra Summit in California. The performance of their materialized views is lower than what you could get if you did your own secondary or separate index table, and that transaction is part of the reason for that. Because they actually lock the records.
It really is.
You get guaranteed consistency.
Yeah.
in all your materialized views.
Yeah, they do. And so they have to lock it, and they're taking care of the lock. We don't have access to that lock over yet. So, but because of that locking, you actually get a slower performance, which is one of the reasons why they don't support transactions, right? Because you don't want locking. We want throughput in the system, right? Okay, so now we can query all the records. And now, just real quickly, I'll show you. Here's the all the records, the whole database now. The other two that came in from the other table. Now we'll add, just to be fun and consistent, we'll add the is marked. We got is red and is marked. Okay, we've got both of those. And then is marked, same thing, I get nulls in there. Now I'll show you how you actually can query this. Okay, so I like to query. I say where person equals 9A and is marked is true. Okay, but remember that has false records. It had false records, has true records, and has null records in there. So I'm going to craft one real quick. So let's just say, we've got that null record in there, or is null, right? We've got a record in there. Can I do this is null check? Guess what? No. The only way to get those null records out of there is to query the whole thing. So because that's a null, I can query by true, I can query by false. I cannot query just to give me the ones that have a null value in that cluster. It just further exacerbates that. Why the heck do they have that where is not null in that material is used? Just seems kind of silly to me. Okay. So now let's just say, obviously, you know, my product owner says that's great. You can query by mark, you can query by red. I want you to give me a query that says, give me the ones back that are true, that red is true, and marked is true. Okay. So, well, I don't know if you guys realize that, but I can't do that, right? I can't do that restriction because my two materialized views, one is red, the other one is marked, right? So let's try creating a materialized view that has, I'm going to put person, then is red, then is marked on there, okay? I do that, and the first thing, at least it's a nice error message. It says cannot include more than one non-primary key column, and that's from the original table, the primary key in the original table. Cannot include more than one of them, and the second one I had is marked, so is red, then is marked, and so is marked is an invalid record, so I can't do that. So the next thought is, okay, well, I've got this table, I've got a materialized view. What if I do a materialized view of my materialized view? Seems simple, right? Let's try doing that. And Cassandra will simply tell you cannot. You cannot create and nest them a materialized view and materialized view. So you can do one thing in it, right? I still want to satisfy my product owner. So I'm going to be real creative. I'm going to create myself, and I could change the original table to the same thing, so just bear with me. I'm going to expose how you do it without materialized views. So you're not 3.0, you're 2.0, or some 2.x, right? So you're going to create a do-it-yourself index table. Okay. In here, I have my person. I have my flags. So I'm going to say that I'm going to put text. I'm just going to say red and mark. I'm just going to throw text in for each one. And then I have my match. And then I have this extra field in here. I'll kind of explain why I added that. It's just for fun. It's something we'll go to. So now I'm going to insert 5 records in here to basically make this do-it-yourself index table in parallel and with my original table. Okay. So there's my do-it-yourself index table, and it has all the records in there. I've got marked and red, marked red. Okay. I'm just throwing out an example. Don't curse me because it's silly. But anyway, all right. Okay, so if I query by flags equal marked and red, I get this guy because he's both, right? Simple enough. Now if I query my original table, because I made it match, right? This guy, this 0, 0, 0 is true and true. So the tables are now the same. Okay? So now I want to update my batch. So I've got this table. Let me just go back to this table. I'll make this bigger so you guys can see it. So I've got this table here, right? And it's got a primary key, a person, then flags, then match, right? So I'm going to update that and just say update the person and set the flags to whatever for this match. I'm also going to update in this batch, and just real quickly, a batch is just a way of applying n number of queries together. You can't go too big. They do have batch size limit, but you can throw 5 records together and they either complete or they don't as a batch. There's no guarantee on the order, which will be compared to here in a little bit. So naively, I create this update statement. I want to update this record for both of them. I get an error. The first error I get right now is that the primary key part flags, so this guy right here, set flags, it's found in the set part. That seems kind of cryptic, but basically what it's saying is you have a value. It's part of your primary key and you're trying to update. You cannot do that. Okay. Remember, this is the primary key, which includes your partition key, and every record and every column in your clustering key makes up the primary key for the record. It doesn't even make sense to take a record and update the primary key. You're not going to normally take your database and say, hey, go update ID 1 and set it to 10. It's just kind of weird. And when you understand that Cassandra data structure, think of that. This is actually stored this way when it gets written to disk, right? So when you query disk, Cassandra gets good read performance and write performance when it writes the value by actually having this stream across all the sectors of the disk, so you can take care of your disk caching, take advantage of your disk caching and things like that. So if I say read, give me all the records for partition key A, right? It just reads the database. It's all the disk is in that order, so it takes advantage of all those things and streams it right out, makes it faster. And if I were to update a part of my partition key or a part of my clustering key, I'm literally moving this from here to here, or this guy from here to there. If I'm updating my partition key, you would be literally moving that record from servers 1, 2, and 3 to 4, 5, and 6. So if you understand the database structure, you don't update anything in the primary key. Okay. So now I create my other query. So now I've learned from that. Okay. Oh. Okay. Make sure all things. So now, I was going to show you a couple queries before I actually ran that. So again, here's my data, what it looks like in the regular table. And then here's the data that marked red. And here's my data for that one record. Okay, I added this write time in here. And we'll get into that later in a little bit. But these basically represent a microsecond level timestamp of when that column was updated. Okay. So now I have my batch. So I've learned, and what I do on my batch instead of doing an update is I actually have to go update the matches and set the first record in the first table, the original table. Then I have to delete my record where it's flagged as marked for this record, okay, for my index table. Then I have to reinsert it into that index table. That's why this materialized views is nice. It's basically doing all that for you. But with 2.x or in a situation where the materialized views can't really represent my data or don't do it well, this is roughly what I would have to do. It kind of makes sense. Okay. All right. So now I added that write time in there because when I query this, we now have this record marked. We get these timestamps in here. By the way, I added that field for write time because this table, without that field, the only thing it has is the partition key and the clustering key. You cannot get the write time of the record for anything that's in the primary key, which is the combination of those two things, right? That doesn't exist. So if you actually wanted something like that to know when this record was inserted into the database, then you would actually have to do an insert, like I did here, where you add this, whatever field you're doing for write time, and you always have to put a value in there for that. If it were null, you wouldn't get a value for that. You wouldn't be able to tell when that record was added. That could be very useful to you, especially if you do what we did and have a mistake in your usage of Cassandra. And I'm going to explain that example right now. Remember how I said that the database does not guarantee the order at all? So I fixed this one. So I ran basically that same batch again, because let's say the situation is the user clicked mark twice and my UI didn't handle it. So I get one request saying mark it is true, and followed by a second request marking it is true. Or the programmer lets them do that and they didn't think about that. What happens? So my batch gets created, it updates the first record, it deletes this one, and then immediately afterwards inserts the same effectively record. And this batch is not guaranteed the order at all. So now I do my select from here. And instead of having 3, like I had up here, 3 records, I only have 2. Guess what happened? Any thoughts?
Actually, in Cassandra, you're guaranteed that delete will always take precedence over the insert or update.
Yeah.
Or batch.
So we ran into this, except for, it wasn't in a batch. Okay, you get that in a batch. We had a situation where we did our Cassandra migration, okay? And we did it in 2 records, because our database is matching, right? So we get that big bunch of data from the lab. They send it to a team in San Francisco. They process the data using Spark and stuff and figure out who's running the team. Then they give me this data. And then I stick it in my database, in this Cassandra database. So, or my SQL Server database. So my migration from that was stop processing data from them, copy all my data in, because I know that the only thing that the users can do is delete records. That's it. That's the only thing they can do. And our data model was so that we had these secondary indexes for the is red, is flag, is favored or red marked or whatever it is. It's is star, we call it, And then there's another thing where we have to go through and figure out that me and JT are cousins, and we have the same common ancestor down in Boone, and so it says that and put that in here too. Right? So those are all secondary indexes. Well, those could change, but I don't care about the secondary indexes. So I just blast all my data in, just insert it. Then I have added some tracking on SQL Server saying, did this record change? Did this record change? It's a flag saying, the last modified. So I go get all my SQL Server records that have been modified since the start of my import. And I go through and simple situation. He's laughing, he knows exactly what happened. We go through and we apply a batch where I say, delete everything. Just clear everything out of our database. Then insert everything. And this thing, remember, Cassandra's writing at 300,000 lines per second. Everything can be async. We do all the A's, we sync up, then we do the next step, we sync up, right? Well, guess what? I had this happen. I did an insert, or I did a delete. I went to new code and hit a delete. Not in the same batch. Any ideas what happened? But same thing, except for it's slightly different. And this is why I added right title here. Okay? What we found is I had a 12-node cluster. This is happening super fast, sub-microsecond, right? Type thing. I inserted, and it goes to one of those nodes. It just picks a random coordinator node. So I picked node A. I didn't specify a timestamp in my query. So that node A, let's say the time on that node A was n, right? And then I do my delete. And then I go to node B, or node 2, right? Node 2, the time is out of sync by 3 milliseconds. And these times are microsecond times. I do my insert at a let's say it's a millisecond pass between the delete and the insert. The delete happens on node 2, which is on 3 milliseconds behind. And so now my insert happens at now -2, my delete happened at now. So when you look at what Cassandra does, and I didn't draw this up, but I'm going to draw it. So when you take a record, okay, and I insert, those initial ones, I did an insert, right? So I have this insert. Here's my partition key, and then my clustering key, and then my value. And the only value I added in there was confidence. So that's why I kept those 3 things were added to my record. Then I did those updates. I did an update. So here's my primary key, which includes, I'm just going to do primary key, partition key, whatever. Primary key is the partition key, cluster key, and the red flag, right? That gets added. Then I did another update for the primary, and this time I updated the marked flag, okay? And then let's say I go through it again, and now we update the red flag again, okay? And this represents time, okay? It's probably at least very visible. So time passes, right? So this is, at time 1, this is time 2, this is time 3, this is time 4. And this, what Cassandra is going to do is going to read this record, get all those values, get this one, and it's got the red column, okay? Then it's going to get the marked column, then get this red column, this guy will be red second, okay? The same thing actually happens for a delete. Same thing happens for a null, which, by the way, you don't want to insert nulls in your database. Don't do it. It's what it added in nulls and a delete, add a thing called a tombstone. Let's say I set mark to, I set it to null. Okay? That mark now has a thing called a tombstone. And a tombstone, I think the default is 30 days is the lifespan of a tombstone.
Yes.
What's that?
10 days.
So 10 days?
One more than your repairs.
Yeah, your repair. Okay. So 10 days. Okay. So if I have a node that goes down, and I have done this much work, the tombstone is there to say that this node went down, this guy got marked as null or deleted or whatever for the whole record, and that node went down, and let's say that node went down for longer than my tombstone time frame. Let's say it goes down for 1 day, and our tombstone is down. But down for 1 day, it comes back up. It's going to get told about this tombstone, and that record now goes away. If that node stuck around, was down for 11 days, never got told about the tombstone, came back up, tombstone's gone, all of this is gone. That node comes back up, it doesn't know about the tombstone, it only knows about these. You do a read, this guy responds, and you now have that record, it's just recovered. It's back from the dead. Tombstones are used for that. And this is how Cassandra takes all those writes and figures them out. These are put in what's called a mem table. It's logged to a transactional if you're durable. And it's put in a mem table, and eventually it gets written out to disk into what's called an SF table. Then eventually they get compacted down. This is one of the reasons why they actually tell you with Cassandra, don't exceed 50% capacity. Because I have all these records in here, and I've got all these on disk, and then I've got to compact them into one record, which is going to be extra data, and I've got to put that on disk, and then I've got to delete it. That's how compaction kind of works. Make sense? And then, so that's how, what we did is we did our write, it added that tombstone at now, right? And then added that insert at now -2, so 2 milliseconds earlier, and my record was gone because my servers, I had 2 problems. One, they're not, NTP is not going to be microsecond consistent. What's that?
PTP.
Yeah. It's not going to be microsecond consistent. And it's not going to, you can put them in different order. So the fix, there's a simple fix for that. I will say, I actually did that.
Jack, you got a partner in crime.
What's that? Yeah.
I still press escape less than good users.
Yeah. So there's a simple fix. What we do is I specifically took this write time select and I set it to way in the future. There's 2 reasons I did that. 1, to explain a mistake I made, and 2, just so I can guarantee that this will work today and not tomorrow. I update my first record at now, so 0, 0. Then I do a delete at 0, 0, 1, okay? Then you do an insert at 0, 0, 2. I've guaranteed that those records ignore his delete page precedence, and I've guaranteed the order of my records in that batch. And I did the same, we had to do the same exact thing with our delete and our insert. We also ran into another issue. Cassandra is based on Java. Java uses epoch time. Anybody here a .NET user? What are ticks? What's the time base for ticks?
I don't know.
So 100 nanosecond increments, that's
They're
1500s.
100 nanosecond increments. What's the base? So an epoch is base 1970.
The .NET ones are somewhere in the 1500s.
They're
Right.
1, the 0, 0, 1. I paid very close attention to converting, because I'm a Java guy, the ticks to microseconds. Had times like 10, I had to think about that through. 100 nanoseconds in their description. I would have rather they had a description of 0.1 microseconds. Makes more sense, but whatever. 100 nanoseconds, what they called it. I paid attention to that, totally glossed over the whole 0, 0, 1. So I do my insert, I got the time from the system. I did my inserts, or my deletes, and then I did my deletes, assuming every time. Then I do my migration is now done. I go and try to update data, nothing updates. Nothing at all. Because, and guess what? Nothing was going to update for any of those records for 1,970 years. Because every single one of them and a timestamp. Cassandra doesn't care if this timestamp on this column is 1,000 years in the future, or 1970 in my case. It just orders them and returns them out. It's very simple. So that's one of the reasons why the speed is there. I'm worried about that time. It also is really, really weird. You could actually, by the way, add a timestamp to the batch as a whole. You just say begin batch using timestamp, and then all of the records. So in the case of ours, we just did deletes, a whole bunch of deletes. We set the timestamp on the whole batch. Then we do an insert on that batch. You could do a whole one. You could have one timestamp for the whole thing, all the inserts at the same time. Actually, something I kind of like with the whole secondary indexes. If I have my main table and my secondary index, I actually like the idea of having my batch all have the same timestamps for all the values.
Just gotta be careful, the source has to be all from the same machine, because
Yes. Yeah.
multiple machines feeding the data, this doesn't work.
Yeah, you get the same problem. So in my case, though, what we did with our migration to make sure we didn't handle that, we actually had these 20 servers all trying to feed the data. And we took our data, again, we just took our IDs, 0, 7, we took our IDs in the SQL server and said, you're gonna do 1, you're gonna do 2, you're gonna do 3, then this server's gonna be 4, 5, 6. We kind of spread it out. When we tried to do chunks, it was sucky because they weren't organized, because people spit in their test and they don't cap the thing, so they gotta recollect, so we have these gaps in our database. We had like 2 million total records in our tests with all those matches associated with it, but only like 1.2 million at the time tests that we had that were actually valid. Some of them were failures, some of them are sitting on someone's shelf, some of them are lost, they never turned back. So anyway, so we had to try to do that. We had this system to distribute across all the client nodes to try to make them all do the same. So because of that, I was guaranteed that I could do that. I didn't care about the times. All I cared about was that this test and all its matches were handled by this one server, and so I didn't have to worry about that. But again, if you get a multi-threaded system, you need to understand this timestamp. It's very, very important to realize that it's this other thing that the microcycle has really created and have a lot of people work on the same thing to run into issues. Make sense? Okay. It's also weird, update matches using timestamp, delete from matches using timestamp, those are the same. Insert matches all the way at the end using timestamp. It's a little bit funky, they're slightly different. Kind of makes sense when you think delete from versus insert, they're slightly different. So it kind of makes sense, but quite frankly, I would rather just put false at the end. Would have been easier for me. Okay, so now I query this guy, and we now, instead of having 2 records for this guy, we have 3. It fixed it, worked great. Okay, all right. So now I'm going to explain how static works. Okay. So let's just imagine that this database that I have here. Think of it as a very simple. I effectively have a DNA test or kit or whatever the product test is. That's what some video is called. No way to think of unit tests and have tests in the system. It's very so you have a test, and it's got the person, right, which is my ID, okay? And then I have effectively matches, right? And my matches have my match ID, right? This is person ID. And then I've got my values, whatever those values are. They're associated with, red, node, star, okay? And this effectively is a foreign key here. Well, in our case, we're ancestry.com, right? So we have trees. That's one of our values. So we actually allow a person to associate their DNA kit with a tree and a person on the tree. So I have a tree, and I'm on my tree. I link my test to Jared Alger. So let's say that we want to put that in here. So I'm going to have my tree ID, and I have my person ID, right? You could just have this one field, you have 2. We actually have it both ways in our system. You can do that. But for simplicity, for this example, I'll just do it this way. So we can actually have this system represented in Cassandra right now. And the way to do that is stacks. So what I can do, then I alter my table, okay? And I'm gonna add 2 static fields, the tree ID, person ID, okay? By the way, when you get in here, it's all lowercase, so Papa Camel, you don't get it in Santa, you gotta use underscore or something different.
You can camel case, then you have to use quotes around your field names.
Yeah, but that's close.
Yeah.
That's like doing the same thing with your, your identifiers and sequence order and putting brackets. So what I get now is I get my person, my match, my static columns, my primary, my partition key, my clustering key, my static columns followed by my key values or name values. So if you look at this guy, if you think about how the data is stored, it looks like this. Partition keys, stack values, cluster key names, cluster key names. Okay, it's a little bit different than dictionary when you do /star, but this is roughly how this is stored on disk. You get the same streaming of disk cache and all those things and read ahead there. Okay, makes sense there? Okay, so now if I do a single query here, let's see, I'm going to update this guy and I'm going to set a tree ID. Oh, it failed. Okay, well, it fails here because I tried to set the person and the match. It doesn't make sense because my tree ID and my person ID are associated with my partition key. They're not associated with my cluster key. Make sense? Okay. So now I'll do it right. I update this guy. I'm going to update the first guy to 984 and 873 because they kind of match the numbers in this UID. And then 105 and 216, same thing. It kind of has its numbers. So now when I update that one, I get it there, and it's the same problem. So now I can do a select distinct on the partition key and the 2 static values, and I get 2 records back if I do a distinct. If I don't do a distinct, okay, I still get all of them. So Cassandra will kind of basically realize that replicate that value like it does for all your partitions. Make sense so far? Okay. Even though it's technically only stored once, it'll treat it like a record in kind of, that's what CQL does. You used to have to do, have I used it before, CQL? I can't remember what it was, what the system was. You used Swift. Was it?
Not Swift.
Yeah, Thrift. Yeah, use Thrift. So before that, you didn't have the SQL-like model. So let's imagine that I say I want to do select distinct, and I'm going to add the match on there. I want to get the distinct match guy, right? With matching. I can't. You can only do the distinct if you have the partition key and your static values. Okay, so now let's select. Now I'm just going to select this portion of my table, right? Now, and I can get this. This is where I say, in a way, you can kind of represent a many-to-one relationship. You also have the whole, I'm not even going to cover it, but there's a column family called that's a set, a list, and a map. And you could do something similar. You could do effectively kind of 3 levels down. And there's some query and searching you can do with sets and lists, but that's a kind of an advanced topic I don't know in this group. I didn't think we had time for that. So now I'm going to go to that right time thing and show you exactly how that works. So to be very clear, we've been kind of messing around with things. All my tree IDs are all the same. I didn't do that person because it'd be roughly the same. My right, because remember, it's only in there once, right? So it's always going to be the same. My right time for confidence was, those actually happen, 40 microseconds apart when I just ran those. Most of that's probably I/O on the console. Same thing for Ismark and host. You can that's one way you can kind of debug through this. There's also a tracing thing you can do with Cassandra. You can actually see when I do a record exactly which node it writes to. It's all kind of cool stuff you can get into and figure out see all that stuff in action. Okay, so now let's see. Oh, let's say I want to get the right time for the partition guy and the cluster guy. You can't. Again, that's why I had that one value, the right time value, so that I could see when that record was inserted. That's just part of the partition, they don't track that. Because that effectively is your inspected. This guy, that guy, the partition guy, the cluster guy, those are not, they're not sorted necessarily, right? They're still sorted in that flow that I showed up here, but they're not, they just don't track that time for you and expose it to you in the same way. Okay, let's see. Any more questions right now? There's one last thing. This is an insert. Do you remember why I added that? Oh, okay. So I just added one insert here where I inserted in the database and I set a way advanced timestamp. So this is just showing you how to set that using like we did in fact. That's all I have. Any other questions you guys want to know? How anything specific to Ancestry? We are hiring, in case you're curious. We're looking for people. My group in particular, a few headcounts starting in January. A bunch of other groups from DNA I joined too. Any questions? Sure. Thanks, guys.
All right, just some brief administrative stuff. So we've been running this meetup, we've been meeting every other month. And after last meetup, we decided that we're actually going to start meeting every month now. And I think that there's been enough interest in how things have been going to sort of alternate between doing a meetup about some sort of real world tool that people can use. Cassandra is a great example of something that sort of straddles both that and paper reading. But I think we're going to sort of try and bounce between practical application and then sort of theory. So on that topic, Levi will be presenting in January. So that's the next topic. Huh? I may have to do February. Okay, that's fine. It may be January, it may be February. Depending on which time Levi goes, that'll be the month that we do theory stuff. And then otherwise we'll do practical sort of tool stuff. CRDTs is particularly interesting because, Jared talked a bit about, of course, how there's all this conflict stuff with timing, and the reason why time rights make a difference is because Cassandra is based on Dynamo. Dynamo actually has two strategies. You can do last rider wins for conflict resolution, but you can also do application level conflict resolution. And if you were to use Dynamo with a different conflict resolution plugin, like an application level one, a CRDT, which is a convergent replicated data type, might be a good choice, and then you wouldn't have some of this stuff where your data gets lost. So anyway, CRDTs will be interesting. I'm going to come up with a list of some other topics. Currently, right now, the schedule for the meetup says that we'll be talking about, on the wrong page. CRDTs right now are scheduled for next August, but that'll be sooner. So I'm going to rearrange the schedule before January. Distributed trust systems, someone said they were interested in talking about that, but I've completely, does anyone remember who or what was interested in that? I don't even know what that was. So that might just drop, okay. But then also Dynamo is on the list. Spark is actually pretty interesting. Jared mentioned Spark as a thing. Spark and MapReduce would both be great to talk about together. So that might be an upcoming topic. And then I actually just have this big list of topics to go over, like including GFS. I think Spanner would be really interesting, Google's thing. I actually feel like I might be able to present Paxos. Like I think I get it at this point enough to be able to present it, which is scary because I think the joke is someone at a distributed systems conference said only 5 people in the world understand Paxos, and I don't. But I think I can present it in such a way that you can get a flavor of it. So anyway, so some topics coming up there. If you have any sort of suggestions or anything about what you want to talk about with the meetup or what's coming up, I'd love to hear about them. Just ping me on any of the things. You can just Google JT Olds, and any of those people are me. So there's a John Olds, and that's not me, but he lives in upstate New York, and you might rather talk to him. So anyway. So that's it. Yeah, let me know if you have any feedback or suggestions, and I'll get the schedule for 2016 lined up here soon. If you want to talk about anything, I am definitely looking for people who want to talk or have things to talk about. I'll come up with a schedule, but the schedule I will throw out the window immediately if someone has a particular topic they'd like to speak about or have some expertise in. So that's that. Thanks for coming. Please take some food on the way out.
Thanks for the food.
Yeah, absolutely. All right, thanks.
Is there a website?